Welcome, everyone, to the AI Factory podcast. In today's explainer, we're going to look past all the hype, all the headlines of the AI boom, to really uncover the economic and technical realities that are quietly reshaping the entire industry. So let's kick things off with this pretty provocative statement, right? This comes from a key figure right at the heart of the AI revolution. And what he's hinting at is that the current path we're on, just building bigger and bigger models, well, that's reaching its limit. The big question is, why? All right, section 1, the problem. AI's invisible iceberg. And to really understand why things are changing, we first have to talk about money. Specifically, the staggering and often totally hidden costs of just running the AI systems that we're all using every single day. Okay, look at this number. $8.5 billion. That's OpenAI's estimated annual loss. I mean, that is just a massive figure, and it points to an economic model that is just not sustainable, even for the leader in the space. So it really makes you wonder, right? Where is all that money going? And this gets right to the heart of it. We all hear about the massive cost of training an AI model, that big one-time expense to create it. But that's just the tip of the iceberg. The real problem, the part that sinks ships, is the hidden cost of inference. That's the relentless day-in, day-out cost of just running the model for every single user query. And that hidden part of the iceberg, it can end up being way, way bigger. Okay, section 2, the core idea, the two halves of AI. So let's dig into this a little more. What exactly is this super expensive divide between creating an AI and actually using it? And maybe more importantly, what is the industry doing to fight back against these costs? Here's a good way to think about it. Training is like years of schooling or writing a textbook. It's this long, expensive, computational marathon that can take weeks or months. But inference, that's like taking a test or using the textbook. It's super fast, just milliseconds, a series of quick sprints. Now, a single query is pretty cheap, but when you're doing that billions of times a day, well, you can see how that adds up fast. So, because of these immense costs, a frantic race for efficiency has kicked off. Everyone is trying to figure out how to make these models cheaper to run, and they're tackling it with all these clever optimization techniques to make models smaller and faster, hopefully without losing too much performance. You have things like quantization, which is kind of like using less precise numbers, and pruning, where you're literally trimming away the useless connections in the model's brain. And you know what? The results are pretty dramatic. We're talking about reducing a model size by 80 to 95% by combining these techniques. And you can do that while keeping most of its original accuracy. I mean, that is not a small tweak. That is a total game changer. All right, on to section 3, the consequence, a shifting AI landscape. Because this relentless push for efficiency, it's not just some technical exercise for engineers. It's creating these powerful economic forces that are completely changing the entire structure of the AI market. So what does that look like in the real world? Well, we're seeing these lean, efficient new competitors pop up. And they're offering similar, sometimes even better performance for just a fraction of the cost. Look at these API prices. We're talking over 96% cheaper in some cases. This kind of price pressure is just commoditizing the whole AI stack from top to bottom. And this is leading to something you might call an enterprise exodus. Basically, as it gets cheaper and easier for companies to run these smaller optimized models on their own servers, they're starting to do just that. We're seeing nearly half of IT decision makers now choosing to develop AI in-house instead of paying a premium for a big cloud API. And this creates a really interesting paradox, a kind of innovation trap. The current market leaders, the big guys, are so burdened by the insane operational costs of running their giant models that they actually can't afford to take the big research risks, the ones needed for the next true breakthrough. So let's get to our final section, the horizon, beyond bigger models. All of this is pointing to a future that looks, well, very different from the last couple of years. So the big question is, what's next for AI? Well, if bigger isn't necessarily better anymore, what does the future of AI actually look like? It seems pretty clear that the era of just scaling up, the throw more data, more compute at it approach, that's coming to an end. The law of diminishing returns is really starting to kick in. So the next wave of progress is going to be defined by something else entirely. We're talking about fundamental breakthroughs in how these models are even built, new architectures. We're going to see a big shift towards smaller, super efficient, specialized models that are great at one thing.
And we'll see more and more AI workloads moving away from the big central clouds back to on-premise servers. It's really about working smarter, not just bigger.
And that leads to one final, really provocative question. Who is going to lead this next wave? Because the companies that discovered these new breakthroughs, they might not be the household names we know today. The very weight of their current success could be the anchor that stops them from making that next big leap. The race is definitely far from over.
We've really just scratched the surface here on these huge shifts happening in the world of AI. If you want to dive a lot deeper into these concepts, I highly recommend checking out the book AI Factory: Architecting Global Supremacy. The link is right there in the description for you.